to the constant velocity practice problems. I believe that was paper C18. Key thing when you're doing these is to show a general formula first, plug in specific numbers, circle answer with units. So that's how you get full credit when you do these on tests and quizzes. So the general formula we use for average velocity, V equals delta x over delta t, that's displacement over time. So when you're only having a simple motion in the positive direction, speed and velocity are the same thing. However, when you're going multiple directions or have multiple types of back and forths or positives or negatives, they're not. So this is actually asking then what's the average speed for a car that travels 400 meters in 8 seconds. So at this point I can still use this general formula because it's a simple motion, 400 meters, 8 seconds, 50 meters for every 1 second. So notice general formula, plug in specific numbers, circled answer with units. Here, this is a school bus traveling 14 kilometers to school in 3,600 seconds. What's the average speed in meters per second? First, I converted kilometers to meters, which we've been through. Then I put the general formula, plug the numbers in, 3.89 meters per second. Fourth one, a student rides her bike home from school, 2.1 kilometers in half an hour. Same thing. General formula, I changed the fraction 1/2 to a decimal, comes out to 4.2 kilometers per hour. This one's a little harder, and if you want, we can put this on your formula sheet as an extra formula. A lot of times people don't need that. So if you're moving at a certain speed and then later a certain or velocity, a different one, the average would be halfway in between. So I showed how you could do that mathematically here. Initial plus final divided by 2, because dividing two numbers by 2 gets you the average of them. So this is 20 meters per second, this is 50 kilometers per hour. For number 7, general formula, 1,400 meters in 10 minutes, 140 meters for every 1 minute. In meters per second, I've got to convert minutes to seconds, so it's the same general formula, but now it's 140 meters over 60 seconds because there's 60 seconds in 1 minute. So that's 2.33 meters per second. 8 and 9 deal with position time graphs, which we'll start looking at today, but this is more of an idea of understanding the difference between distance and displacement. So distance is the total distance covered. So if I start here at 1 meter, end at 12, during this region I travel 12 meters, or 11 meters. Here, if I start at 12 and then go back, and it was hard to know whether you went back to 5 or 6, I think I said 5, that's 7 meters. So the total distance traveled, you went 11 meters in that direction, 7 meters in that direction, that's 18 meters. The displacement is just the change in position. So I start at 1 meter, end at 5 meters, that's a displacement of plus 4 meters. So how to get the average velocity? Well, it's whatever you had here for displacement divided by time. 0.5 meters per second is what I got. How fast did I walk during the first 5 seconds? Well, there's 0 seconds, there's 5. Ended up at 12 meters, started at 1 meter. So 11 meters is the distance traveled, 5 seconds, 2.2 meters per second. For number 9, I would like you to show some work with this. So it's asking the total distance traveled. So from here to here, that's 8 meters. The person's not moving from 4 to 6 seconds. They are moving from 6 to 8 seconds. They're moving backwards. But for distance, we just add that up. So that's another 4 meters. They're not moving here. They are moving here. So that's going from 4 back to 8. That's another 4 meters. And then from here to the end, they're going to be moving 8 meters. So I add all those up, that's 24 meters. The displacement, well, that's a difference in position. The coach starts at 0, ends at 0, 0 meters displacement. Since velocity is displacement over time, 0 meters over 16 seconds is 0 meters per second. When did the coach have the greatest displacement from his starting position? That's the farthest away. So 8 meters in this region from 4 to 6 seconds, and 8 meters at 14 seconds. And the coach was moving the fastest here at the end because the position's changing the most rapidly. We can tell that because it's the steepest slope. So if you thought we were done with slope discussion, we're not done with slope discussions. So just a heads up on that. I wouldn't necessarily expect you to have known this, but I would have expected you to be able to guess it, or at least have a reasonable guess. Obviously, it's not during the regions when the position isn't changing. So hopefully that helps out.